So in this video today, we're going to go over the Quiz 9/CFA3 review. Okay. So it says, given the following right triangle, solve for the missing side length. So if you remember, for this one, we're going to use the equation a squared plus b squared equals c squared, keeping in mind that c is always going to be our longest side. Okay. So when we, on this first problem, in that c is also the hypotenuse, right? So where is the hypotenuse? It's opposite the right angle. So that's our hypotenuse, right? So that's going to be equal to C. So it doesn't matter which of the other we make, A or B. So I'm just going to say 12 squared plus 5 squared. And you can put that directly in your calculator and find out what number that is, and that's going to be C squared. So that would be 144 plus 25, which is equal to C squared, right? Or x squared in this case, because that's what's there. So let me write x squared here. So that's going to be 169 equals x squared. So we would take the square root of both sides. And again, you can do this on your calculator by doing second x squared, and that gives you 13 is equal to x there. Okay. So here again, on the next one, we are going to do the same thing. So I'm going to label this C first. And again, it doesn't matter which one we label, A or B. So I'm going to do, this is A, and this is B. Okay, just for y'all's sake. So this is going to be x squared plus 6 squared equals 10 squared, right? So that's going to be x squared plus 36 equals 100. Subtract that 36 from both sides. So that gives us x squared is equal to 64. Remember, again, we're going to take the square root of both sides. So the square root of 64 is 8, right? Okay, so this next one, same thing. Notice again, this is our C because it is opposite the right angle. So I'm going to make this one A, this one B. So I'm going to say 8.6 squared plus 5.7 squared, and set that equal to our x squared. Okay. So when I did this, I got 73.86 for that. And you guys can put this directly in your calculator. You don't even need to know these numbers because you can just do the 8.6 squared plus the 5.7 squared and then get a value, right? So when I get that value here, I got 106.45. That equals x squared. Then we're going to take the square root of both sides, right? So we're going to take the square root of this and this. So when I took the square root of 106.45, trying to find it on my paper, y'all, I got 10.32. So x is equal to 10.32. Okay? All right, here again, let's label our A, B, and C. So this would be our A. This would be our B. And obviously this is equal to our C because, again, it's our hypotenuse and it's opposite the right angle. So we're going to say x squared plus 9.3 squared is equal to 15.3 squared. Okay? So we get x squared. When I do the 9.3 squared, I got 86.49. And when I square the 15.3, I got 234.09. So then we're going to subtract the 86.49 from both sides. So x squared is going to be equal to 147.6. So then remember, we got to take the square root of both sides, right? So that means x is going to be equal to 12.15. Okay? The next three problems say, given the following triangles, identify if the triangles are right triangles or not. So that means that a squared plus b squared should equal c squared. Now remember, if it was obtuse, c squared would be bigger than a squared plus b squared, and if it was acute, c squared would be smaller, okay? So first thing I got to figure out is that 133, square root of 133, what number is that? So I'm going to do that because I need to figure out which is the biggest side. I got to figure out which is c, okay? So I'm going to take square root of 133. And that's 11.5. Now, I'm not going to use that number to work my problem, but it just tells me which one I'm going to make my C, right? Because the biggest side is going to be C. Yes? Okay. So we're going to say square root of 133 squared plus 6 squared is going to be equal to 13 squared, okay? So now remember, if you have a square root and you square it, they cancel each other out. They're opposite operations, right? So this is canceled by that. So that just leaves us with that 133. That's going to be 36, right? So is that equal to 169? Because this 13 squared is 169. Well, 33 plus 36 is, guess what, 69. So that's 169 is equal to 169. So the answer here is obviously yes. Okay. So here we go again. Let's do the square root of 135. I did that, and I got 11.6. Okay, pretty close to what the other one was, 11.5. So once again, this is going to be our C. Okay, so it doesn't matter which other one, if I make this A or I make the other one A, it doesn't really matter. So we're going to make that A and B. Okay, so here we go again. I'm going to say the square root of 135 squared plus 8 squared. Does that equal 14 squared? So remember again that this cancels out, right? So we get the 135 plus 64, and that's 196, right? 14 squared. So we're going to add those two together. I got 199. That does not equal 196. So the answer here is no. Okay, the next one, again, I'm going to multiply 2 times the square root of 65 and see what that is. In my calculator, again, 2 times the square root of 65 is 16.12. 16.12. Okay, so that's going to be my C because it's the longest side. So this is going to be A and this is going to be B. Okay, so we're going to do 8 squared plus 14 squared and see how that compares to our 2 square root of 65 squared. And I'm going to talk to you about how to do that, okay? So this is going to be 64, and this is going to be 196, and this is going to be, so you know, we're just going to, yeah, give me just a second. Okay, so you're going to apply this to both things, okay? So that means you're going to do 2 squared, and then you're going to do that square root of 65 squared, right? Okay? So 64 plus 196 is 260, right? And then what is this over here? 4 times, remember, these two cancel each other out. So this cancels this, so we're left with that 65. And guess what 4 times 65 is? It's 260. So that's equal, so again, it's yes. So on this next one, it says, Owen walks to school each day. He travels 8 blocks west, 3 blocks north. If he could walk in a path directly from his house to the school, what would be the length of his walk in blocks? Okay, so let's just see if we can figure this out. I don't know if y'all know this. I'm going to show you. North, obviously, there. South, I think you guys all know that. But west is over here and east is over here, okay? So I'm going to start here at the middle, okay? And I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 blocks left, because that would be west, okay? And then it says 3 blocks north, so I'm going to go up. Wait. Yeah. I don't know if I got that on the thing or not, y'all. So 1, and then we're going 3 blocks north, so we're going to go up 1, 2, 3, and I'm going to put that 3 over here, okay? So what they want to know is if, so this is what it took us to get to the school. The school's over there, right? So then it's, no, actually, take that back. The school's up here. Sorry. So they're asking us what would be the distance if we went straight there, right? So they're asking us for the hypotenuse, right? So this is our C. So again, we're going to make this our A. We're going to make this our B. So we're going to say 3 squared plus 8 squared. That's going to be equal to our C squared, right? Okay, so that's going to be 9 plus 64 equals C squared. So that would be, what is that, 73 equals C squared. So we're going to take square root of both sides. And that can't be simplified. 73 is a prime number, y'all. So C is going to be equal to, if we want to actually find the actual distance in blocks, it would have to be the square root of 73, or we could say that it was 8.5, because that's what it would be if we rounded that. If we take the square root of 73, it's 8.5, okay? Blocks. Got it? All right, this next one says, given that the side lengths of A is 10, so we're going to put the 10 where A is. 10 is right here, okay? And that B is 24. Solve for the area of C, okay? So remember, area of a square, square C, so area of a square is what? A side times a side, or a side squared, right? Okay, either one. So when we look at this, we want to be able to find what C is, right? So notice that we have our A and our B, right? So we're going to go A squared plus B squared equals C squared. So we're going to go 10 squared plus 24 squared, and let's see if that equals our C squared, right? Okay. And remember, if this is a side squared, then wouldn't that be C times C? So whatever we get here when we do 10 squared plus 24 squared is C squared. And I'm going to show you that to you. That's 100 plus 576. Oops, sorry, that's supposed to be a plus there, y'all. Equals C squared. So that is 676 is equal to C squared. And remember, C squared is the area of the square, right? So that's our answer right there. Now, if you were tripping and you wanted to figure it out because you didn't understand that, then you could take the square root, right? So that would give you 26 is equal to C. But again, remember, we're doing 26 times 26, right? And that would still give us 676, sorry. All right, this next one's a little tricky, so we're going to talk it through. So given the trapezoid ABCD, solve for the following pieces. Solve for the perimeter of the trapezoid. So I need you all to notice something. So if I go 1, 2, 3, 4 up, and 3 to the left, that's a triangle right there, isn't it? So that is the same as this triangle over here. Y'all see this triangle over here? It's 1, 2, 3 by how tall? 1, 2, 3, 4. Same triangle that's over there on the right. Y'all see that? So if I want to find the area or the perimeter of this shape, I could just count 1, 2, 3, 4, 5, 6, right? And then how tall is it? 1, 2, 3, 4. So the height here is 4, which means the height over here is 4. This was 6, which means this is 6. So we could do 2 times 4 plus 2 times 6, or we could just add them all. Either way, right? So this is going to be 8 plus 12, which is 20, okay? So basically that allowed me to move that triangle over to the left, over to the right, okay? And then it says solve for the length of the diagonals. Okay, so the diagonals AC, so if I look at this diagonal AC right here, and then DB, they're going to be the same length, right, guys? Hopefully you can see that. I'll go ahead and draw them. DB is right there. They're going to be the same length. Okay, so what I also noticed is if I close up this shape up here, do y'all see this? I now have a what? A rectangle, don't I? Where I have a height and a base, yes? So that means, watch this. If I draw that diagonal right there, then I have 6 times 4, right? Y'all see that? Is the area, right? But we don't need the area. What we need is what? We need to make this our A, make this our B, and this is going to be our C. Y'all see that? That's going to give us the ability to solve for the diagonal. So we're going to go 6 squared plus 4 squared. That's going to be equal to our C squared, which is our diagonal, right? So that's 36 plus 16 equals C squared. So that's going to be 52 equals C squared. So the question is here, how do they want us to give the answer? And they didn't really say. So if the answer was a simplest radical form, then we might want to take that 52 and start factoring it, right? 52 is the square root of 52, yes? Because we're going to take the square root of both sides, okay? So if we start factoring that, that's going to give us 26 here. That's going to give us 13 here. Notice we have the 2 repeated. Y'all see this here? Anytime you have a number repeated, then that means that you're going to put that back together and put it back under the radical. So that's going to give us the square root of 4 times the square root of 13, right? And we know what the square root of 4 is, don't we? We do. It's 2, and then we're going to leave this as the square root of 13, okay? That would be our answer if they wanted it in simplest radical form. Now, obviously, we could just take the square root of 52 in the calculator if they actually wanted to measure, right? So if they wanted an actual measure, then x would be equal to, or our, diagonal would be equal to 7.2, okay? All right, let's look at this next one. It says, given the following square has a diagonal length of 16, so I'm going to draw that. 16, right? Solve for the perimeter and the area of the square. So this is what we know. If this is a square, we did one of these in class, right? Then we can use the formula for a 45, 45, 90 triangle, right? Because if those are congruent, then we know these are congruent, the angles, right? So if the sides are congruent, then we know the angles are congruent. So this is a 45 and a 45, right? So that means that this measure right here is our h, right? And this is our L. And our formula for our 45, 45, 90 triangle is h is equal to L square root of 2, yes? So we have h, so that's 16 is equal to our length, and we'll just put L's up here, L and L, right? So that's L square root of 2. So we're going to divide both sides by the square root of 2, right? Okay. So we could do that in the calculator and get an actual measure. And again, the question is, how do they want us to give this to them? Okay. So do they want us to give this to them as a radical or not? Okay. So we're going to keep going, because if you remember from the notes, we can't have a radical in the denominator. So we're going to multiply this by that square root of 2 over the square root of 2, because anything over itself is 1. So that's going to give us 16 square root of 2. And what is that right there? Isn't that going to be the square root of 2 times 2? So that's going to be 16 square root of 2 over the square root of 4, which is what? That's equal to 16 square root of 2 over 2. And notice this right here can be reduced, yes? So the answer to our length is going to be 8 square root of 2, right? So that's equal to the length of one side. Now this is a square, right? So all 4 sides are congruent. So if we find 1, then we can just multiply that times 4, right? So perimeter is equal to 4 times the side, yes, of a square, because all the sides are the same. So we're going to do 4 times 8 square root of 2. That's going to give us 32 square root of 2. Remember, the only way you can do something underneath the radical is if you have something else underneath the radical, okay? So now area of a square is what? A side times a side, or a side squared, right? That's what it is. So again, we have our side, right? So we're going to have 8 square root of 2 times, or do it times itself or square it, okay? So if we square it, we're going to multiply this times both things there, right? We're going to apply it to both things. So that means we're doing 8 squared times the square root of 2 squared. And remember, once again, that these two things cancel each other out. So that's going to be 64 times what? Yes, 2. So that means our answer is going to be 128. Okay? Now this one does come out to be a whole number, okay? All right, let's go on to the next 2, and then we're done. All right, so this one says, use the information to answer the following questions. Consider the following triangles. So we have triangle ABC, and we have angle A and angle B. So what we're going to do is we're going to add 85 to 25, and we're going to actually get that number. And I got 110, and we're going to subtract that from 180. 180 minus 110 is equal to 70, right? So that's going to be the measure of angle C, isn't it, y'all? Okay, so that's going to be our process for all of these. So we're going to do 85 plus 60. 85 plus 60 is equal to 145. So the measure of angle, so we're going to subtract that from 180. Again, I'm not going to show you every step every time, y'all. So this is the measure of angle. So we got S, this is going to be T. That's going to be 35, right? Because it was 145. Yep, that's right. Okay. So the next one, 85 plus 70, that's going to be 155. If we subtract 155 from 180, then we get the measure of X. So we would need the measure of angle Y. That's the one that's missing. So that's going to be 25. Let me put degrees on these, y'all. Okay, then this one we've got 35 plus 25. That's going to be what, 60? And we're going to subtract that from 180. So the measure of angle N here, because that's the letter that's missing, is going to be 120, right? because 180 minus 60 is 120. And then we got 60 and 85, or sorry, 60 plus 25, that's going to be 85. 85 from 160, or from 180 is the measure of angle, so we got E, so we're looking for G, right? The measure of angle G is equal to, what do we say, 85, 95, right? 95 degrees. Okay. So now what we want to do is, do we have any that match? Okay, that's what we're looking for, because it says which pair of triangles are similar, right? So the first one has 85, 25, and 70, right? So these are our third measures here that we're looking for, y'all. So we're trying to compare all three, okay? So the first one is 85, 25, and 70. So I got 85, 60, and 35. No, 85, 25. Oop, there we go. 85, 85. Then we've got 25 here and 25 there. And we got 70 there and 70 there. So let's just keep checking. 35. So I don't have another one that has 35 except, let's see, 35 and 25, right? So that definitely doesn't match. Okay, and then 60. So yeah, I think our answer is ABC to XYZ, right? So that one right there. So you're looking to make sure that all three angles are the same. That's what you're doing, okay? So then it says state the postulate that proves that two triangles are similar. So we got an angle right here that's shared by both triangles, right? So if we were to say triangle HKL is similar to what triangle, y'all? So now look, we got another pair of angles right here, right? Don't we have a pair of angles right there that are congruent? And they're congruent because they're corresponding angles, yes? So that means HKL is going to be similar to what? Or sorry, it should have been HKJ. Sorry, I was going, you know what? Let's just do little big. Let's do little big. So let's do the top one, HLI. HLI, that's this one right here, right? And what is it similar to? This one right here, HKJ. Y'all see it? Is similar to triangle HKJ. By what? Angle, angle. There you go. All right, so the next one, now this one, the first one we did showed that there was a pair of parallel sides, right? So we could use that. This next one doesn't show us that. So we know that this angle up here is going to be congruent, right? In both triangles. So let's look at our little triangle up here. So this is triangle ABC. Let's just call it ABC. Oh, you know what? It's got ABC and ABC prime. Okay, so that's really kind of wild. So we got A prime, B, and C, that triangle. We're going to figure out what it's similar to, right? So is it similar? That's what we got to figure out first, okay? So we do have an angle, right? So angle B is congruent to angle B up there at the top, yes? Then we're going to compare a side to a side. So we've got this 4 over here, and we're going to compare, you know, I just covered up the number. That is not going to help us, is it? So we're going to go 4. Okay, pen. 4, and then we're going to compare that to our whole side, which would be what? 6 plus 4, which equals 10. So we're going to do a 4 over a 10. What's that reduced to be? 2 goes into both, so it's going to be 2 over 5, right? And we're going to compare that to our other side again. So we're doing, again, the little triangle, which would be 2 over the big triangle, which would be 2 plus 3, right? 2 plus 3, what is that? 5, yes? So that's 2 over 5, right? Again. So we got the same ratio, and we've got an angle. So, yes, we can say that these are similar, right? Okay, how? So first of all, let's write our similarity statement. So we had that A prime to B to C. Oh, you know what? I didn't do that right. Should have been C prime, right? Little triangle. Then we're going to do our big triangle, okay? So we're going to do it in red. So our triangle here, triangle. So if we started with A right here, we got to start with that A right there, right? So that's A. And where do we go? We went back up to that B, right? So it's going to still be B, not B prime. And then where are we going? To C, right? So, and, yep, those are similar. Now, why are these similar? Okay, we had an angle, right? But we had sides over here. Then we have sides over here, and then we had an angle up here, and then we had sides over here. So this is similar by side, angle, side. Okay?